Welcome to the homework video for the final day of distance and speed, chapter 5, lesson 3, day 2. Extra practice is found on textbook, page 269 to 270, numbers 3 through 7. So a car travels at a speed of 55 miles per hour. Ooh, as I go through these, you could just jump right to the calculation, but if you remember from class, we had a set of 3 formulas that were really pretty similar. So we had speed equals distance divided by time, distance equals speed times time, and time equals distance divided by speed. So these are all really similar and could be really easy to mix up. So as I go through these problems, I'm going to do more than just the calculation. I'm going to take a moment and do a quick rate line that will make sure that I'm doing the right math. Because even if I do accurate math, if it's the wrong math, it doesn't matter. So our car travels at a speed of 55 miles per hour. So my units are miles per hour. So that means our distance per time. And so that whole thing is our speed. How far will it travel in 5 hours? How far will it travel? So that's a question of distance. How far will it travel in 5 hours? So that is our time. So I'm going to set this up with my rate bar. I know this is miles, this is hours, and they give us our unit rate, 55 miles in 1 hour. And they are asking about 5 hours. So we need to know that piece of information there. So if I do 1 hour times 5, I get 5. And so 55 times 5 is going to give us our time there. And so it looks to me like we are taking our speed of 55 miles per hour and multiplying it by the amount of time. So that does fit with what we know about distance right here. Distance equals speed times time. So 55 times 5, that'll be 250 plus 25, and that is 275. So that car will travel 275 miles in 5 hours. So looking at question number 2, a school bus travels at a speed of 48 kilometers per hour. So they tell us our speed with our units of kilometers, which is distance, per hour's time. And how long will it take? So it's asking about time. How long will it take to travel 120 kilometers? So we know our time and we know our distance. Now, I have such a hard time remembering these without having to go back and look at them. So I am going to do, again, a rate line. They tell us kilometers per hour. We know it's 48 kilometers in 1 hour. And they're asking us about 120 kilometers. So 48 times something is going to equal 120. And I know from earlier math lessons that 48 times something equals 120. The easiest way to solve this is 120 divided by 48. And so when I do that, I know a 48, this could be a 96. No, it could be a, 96. 96 divided by 48 is 2. And then I'm left with 24. Ooh, 24 divided by 48. That is the same as 1/2. Because I know 24 is half of 48. So that must mean that it is 2.5 times to get there. So that will take us 2.5 hours. So it will take 2.5 hours. So this is asking how long will it take, asking about time given distance and speed. So I am going to go look up here at my equations, and I know that time equals distance divided by speed. So our distance was 120, and our speed is 48. So if I look at that, this expression right there is exactly what I solved right there. So based on my image, or based on my little quick sketch, and based on the formula, I know I've got that one correct. A bee flew at a speed of 9 inches per second. So we know our total speed is 9, and we are measuring in inches per second. So it travels a distance. So we know our distance is 81 inches. And how long did the bee fly? We are asking about the time. So again, we don't know the time. And from up above, I just did that time equals distance divided by speed. So our time will equal our distance of 81 divided by our speed of 9. And that means our time is going to be 9. And this is 9 seconds. Now, there's nothing visually or nothing obvious that helps me confirm that that is the correct operation. So I'm going to quickly do a little rate line to make sure that this work is correct, because I don't want to do a silly mistake. So this is inches per second, and it travels at 9 inches in 1 second. We need to know how far for 81. So 9 times 9 will mean that it took 9 times as long, so that'll be 9 seconds. Great. That checks out. Question number 4. Jerry cycles for 72 kilometers in 1.5 hours. He continues to cycle at this rate. How many kilometers will he travel in 3.5 hours? So, it's asking us about distance, which I think we color-coded red. So it's asking how many kilometers, what is the distance in this amount of time? But I notice that here, this speed that they give us, I wonder if it will work if I just keep that speed, because it's not in a unit rate, so that seems a little bit tricky to me. So already I'm seeing a problem with using the formula, where our formula of distance, gotta go up and look, distance equals speed times time. So I can't remember, I don't know if this works where my time, if it's not in a unit rate, does that still work out? So I can either calculate the unit rate, or I do know that 1.5 hours, if I think of it like here's 1 hour, and then here's a half of another hour, and this is 72 kilometers. If I chop this in half, that means 3 of those units equals 72 kilometers. So that must mean that 1 unit would equal 72 divided by 3. And 72 is a 60 and a 12. 60 divided by 3 is 20. 12 divided by 3 is 4. So 1 unit equals 24 kilometers. So that's helpful, because now if I think about, I need 3.5. So if I do 1, 2, 3 and a half, if each of those halves are, now I can chop that up. Not that one. So this 3.5 is really 1, 2, 3, 4, 5, 6, 7. And each one of those is 24 kilometers. So we have 7 units of 24, or 7 times 24, which is 7 times 20, and a 7 times 4, 168. So it looks like in that amount of time, Jerry will travel 168 kilometers. Awesome. So let's check and see. Now I am curious. Like, what if we just plug this in? Our speed, we know we can write, this is 72 kilometers per 1.5 hours. And I know I can write this like it is a fraction. So I wonder if we plug this in as 72 over 1.5, and we're multiplying that by 3.5. So already this math seems like it's going to be a lot more difficult than what I really want to do. But you know what? Yeah, I mean 72 times 3.5 and then dividing that by 1.5, I guess. So here we go. I know if this is over 1, I need to multiply straight across first. So over on the side, 72 times 3.5. Swoop that over once. 5 times 2 is 10. 5 times 7 is 35, plus 1 is 36. We're moving over one place. 3 times 2 is 6. 3 times 7 is 21. So we have, and I need to move that over one place. So this means our distance equals 252 1/2. And I know that a fraction can be rewritten as division. So now I need to do long division but I'm going to do this as a proportional relationship. So bloop, times 10 times 10. So this is 2520 divided by 15. So as you can see, yes, this formula does work out, but I mean, this math is so much more complicated than what I've done on the other side, but we're here. So I'm going to keep going. So 15 goes into 2 0 times, 15 goes into 25 1 time. And we're left with 10. Now if I bring down that 2, I know that 15 goes into 102. Oh man. So 15, 30, 45, 60, 75, 90, 105. So it doesn't go into it 105. It does go into it 90. So that's 1, 2, 3, 4, 5, 6. 6 times. 6 times. And that's 90. So 2 minus 0 is 2, and 10 minus 9 is 12. And then we bring down that bloop. So we have 127. So 120 is 8. So it goes into it 8 times 120. So I do get 168, which is the same as what I got right here. But look at all those extra calculations. Barf. That's no good. So we're going to look, so that was with, here's a bar model. Here is with the formula. But we do have another option. We could have calculated the unit rate. So I'll do that here. So if we know 72 kilometers per 1.5 hours, we could do 72 divided by 1.5, 1.5, and that will get us our unit rate. Again, dividing by 1.5 doesn't sound great, but I am going to use the proportional relationship of times 2. So this is 144 divided by 3. Because if I double both of those, that means I'm traveling twice the distance in twice the amount of time. So the rate is staying the same. So a 144 is going to be a 120 and then a 24. And I know 120 divided by 3 is 40. And an 24 divided by 3 is 8. So that's 48. So this means that that Jerry cycles at 48 kilometers per hour. So now to figure out 3 hours, I need to do 48 times 3.5, rather, because we're finding 3.5 hours. So again, this teal work still seems like a lot more work, but 48 times 3, and then 48 times a half. I'm running out of space, so I'm going to do this down here. So 48 times 3 is 144, because we just did that right here. And then 48 times a half is 24, because half of 48 is 24. So when I add those together, I get 168. So we have 3 very different ways that all got us to the same answer, but to me it feels like that purple way is the most straightforward, with the fewest opportunities for mistakes, just in the computations alone. So let's look at this challenge one, or hopefully I have more space. Okay, a car travels at a speed of 120 miles in 2.5 hours. How far will it travel in 30 minutes? So we could calculate the unit rate to figure out miles per hour, or we could do our little bar model-y guy. And I'm feeling like that bar model-y guy might be good. So let's look. We have 2.5 hours. And so that would be, here's 1 hour, here's 2 hours, there's half of the next one. And this is 120 miles. So I'm going to chop these in half, because that means I have 5 units is 120 miles. So 1 unit is going to equal 120 divided by 5. And 120 divided by 5 is 120, so that is equal to 24. So if 1 unit is 24, This is asking how far will it travel in 30 minutes? Well, that seems really foolishly easy. If this is 1 whole hour is 2 units, a half hour is 1 unit. And I know that a half an hour is equivalent to 30 minutes. So 30 minutes equals 24 miles. I feel like I should have flip-flopped this one and made Jerry's problem the challenge, because that one is a little bit more complex. So let's see. I just want to look at this with the unit rate style. We have 120 miles in 2.5 hours. So that's, I'm going to double those. So that's 240 divided by 5. Well, 200 divided by 5 and a 40 divided by 5. 200 divided by 5 is a 40, and a 40 divided by 5 is an 8. So we get 48 miles per hour. So if we need to know the number for miles per half hour, it's going to be half as many miles, which would be 24. So unit rate wasn't too bad on this one, neither was doing those little bars there. So oftentimes there's going to be a strategy that makes the most sense, but definitely taking a moment to do a quick model is going to be really helpful, so that way you don't have to memorize these and you can be certain that if you did use a formula, you used the right one.